Hello, thank you so much for joining us today. We have Ryan Allison on the line to give a presentation on phase 2 of the Aquatic Restoration Initiative, where we went out and did some aquatic and riparian invasive species management and initiated some native habitat restoration work as well. So Ryan, I will let you take the floor.
All right, thanks, Brittany. My name is Ryan Allison. I'm a project manager and ecologist for Cardno, and I've been working with the project team throughout 2021 to implement some of the requirements, or all of the requirements, put forth in the RFP that we responded to last winter. So if I can get my screen to advance here. Sorry about this, Brittany. I don't know why it's not advancing.
No problem.
There we go. So just a brief background on some of the tasks set forth in the request for proposal. So task 1 was to suppress purple loosestrife at all project locations. That's Deer Creek, Sandy Creek, and South Sandy Creek. Cardno's task was to assist TNC and prison staff with obtaining permits along with providing labor and equipment for a beetle release. Task 2 involved the suppression of Japanese knotweed at Sandy Creek and South Sandy Creek primarily. This work was laid out in the RFP as controlling approximately 2.03 acres between the two creeks. And the RFP really left it up to contractors to determine what methodology they would use. So our team chose chemical and mechanical means as the two means of going about this. Task 3 was suppression of common reed at South Sandy Creek. There's approximately 0.3 acres of Phragmites growing out on a river bend at South Sandy Creek that needed to be treated. Task 4 was habitat restoration at Sandy Creek and South Sandy Creek. And this consisted essentially of revegetating all of the areas that had invasive species treatment performed on them in order to facilitate native plant reestablishment within those areas after the invasives were removed. Task 5 was the creation of an outreach interpretive panel for South Sandy Creek. The responding bidders were to design, print, and install a weatherproof exterior sign at South Sandy Creek. And finally, task 6 is a little bit of a catch-all, but it's resilient and connected landscapes at all project locations. Essentially, 10% of the overall budget was meant to be set aside for additional invasive species control and or habitat restoration work adjacent to upstream, downstream, inland of the various treatment areas. So task 1, I'm going to go through here basically task by task and talk about what was performed for each one of those. So my apologies on that. My PowerPoint just stopped on me. Thankfully, mercifully, it came right back. Task 1, suppression of purple loosestrife at all locations. This item was listed in a joint application form submitted by the project team in June of 2021. But honestly, we got a little bit of a late start on this. The contract wasn't really fully in place until the very end of April. Project team and planning started in May. But due to a variety of reasons, some scheduling, some just a lack of material in the market, and some COVID related, there really weren't any beetles available for the project team to acquire and release. So this part of the project actually was not conducted in 2021. So consequently, the project team took the funds that were going to be used for transporting the beetles to the site and releasing them, and utilized those for additional invasive species control work that I'll talk about a little bit later in the presentation. Task 2 is the suppression of Japanese knotweed. Cardno's treatment approach here is to focus on selective herbicide applications. What we decided to do was go with stem injections for all knotweed stems within 10 feet of the creek. And that utilizes a concentrated rodeo herbicide, essentially straight concentrate out of the bottle. And then for everything 10 feet and beyond from the creek, we did foliar applications. And that was essentially a 3% rodeo solution and also included a non-ionic surfactant and then a marker dye, just so we know where we've been. We also implemented selective biomass reduction. This was primarily done on the north side of South Sandy Creek, just to cut down and hopefully speed up the mulching and the composting of some of the dead standing thatch from the Japanese knotweed. The initial treatments began at the very beginning of July, but July was a pretty rainy month in this part of New York, and we had really high water conditions in the creek and got shut down after 2 days, and we're only able to do about 25% of the knotweed treatment during that first mobilization. The crew remobilized later in July on the 26th and worked through the 30th, where the remaining 75% of the stem injection and foliar application work on the Japanese knotweed was conducted. Following that, in September, there was a follow-up application to all of the treatment polygons, where a combination again of foliar and stem injection treatments were performed, although most of the areas treated with stem injection had near 100% kill. So there was very little follow-up that needed to be done in those areas. The crew estimated visually there was a roughly 80% reduction in the overall presence of knotweed after the first full treatment. It's difficult to tell at this time, but we expect that when reevaluated in the spring or early summer of 2022, that we're going to see in excess of 80% mortality of Japanese knotweed in the treatment areas. Herbicide treatment areas where biomass removal was conducted on the north side. It was a total of 1.4 acres, and the treatment area where there was no biomass removal conducted was 1.3 acres. And this figure kind of summarizes that. So the inset photo here is from the request for proposal and is sort of generalized, but shows where the location of the knotweed was known from the RFP preparation. And it really kind of, the polygons there stuck to the immediate riparian edge. What our crew did in the larger photo shown here is map the actual treatment areas, which ended up extending somewhat inland and give a more precise location of where exactly these are. So this data was shared with SLILO Prism. So in 2022, these areas can be re-examined and reevaluated to see what exactly was the control. The green polygon on the North Shore indicates the areas where biomass reduction and mowing was done, and the yellow area shows where there was no biomass reduction occurring. Here's a sample photo of one of the areas on the North Bank where knotweed has been treated. The stems have been retreated and re-injected at this point. So this is from September of 2021, and the biomass reduction mowing has been completed here. So there's more light getting down to the ground. The idea is that there's going to be more of an opportunity for some of the invasive species to grow and reestablish in these, native species to grow and reestablish in these areas rather than the invasives. The inset photo here, this is a very difficult process to document because when our employee is in the middle of a knotweed patch on the very edge of the creek, injecting stems with rodeo herbicide. It's a painstaking process. It takes a long time, but what that does is make sure we don't get any herbicide in the water and don't have any off-target exposure with the herbicide. As he makes his way through the patch, injecting stems, he actually marks the stems with a marker paint to know where he's been and make sure that he gets everything covered in there. Moving on, task 3 is suppression of common reed. This work was done alongside the knotweed reduction in late July and late September. This was a combination of foliar applications using 2% rodeo and hand wiping target plants within 10 feet of the water's edge. Again, this is just to minimize the amount or the potential for overspray or getting any herbicide on the water. We wanted to keep it all on the target plants. The initial application was done in late July, and the follow-up application was conducted in late September. And as with the knotweed locations, the crew noted an overall mortality of somewhere north of 80% for the Phragmites area. So that was after the first treatment. We expect that number after the second treatment will be somewhat higher. Task 4, habitat restoration. As these treatment areas were largely devoid of any vegetation following the series of applications, they were essentially monocultures of invasive species. We wanted to do what we could to encourage reestablishment of native species in those areas, so they don't just reestablish as the same invasive or another invasive species that would be a problem. Overall, we believe that natural recruitment from adjacent areas is going to be the most likely and primary source for revegetation. Most of these areas are surrounded by native vegetation that are going to seed and grow into these areas. But in order to help speed that up, in coordination with TNC and Sliloprison, we developed a seed mix that uses native species that are known to be on site or are local to the area, found in the county, and appropriate for the conditions noticed on site. So this seed was actually spread by hand into all the treatment areas on November 23rd of 2021. And the box here shows the species that were utilized. So these are all, this is the native species, how many ounces of seed was used. And then there was no cover crop spread with this. So what we actually used a pine sawdust as a carrier to help spread the seed a little bit more evenly across all these areas. This is a photo of one of our technicians, Steve Basinski, who's spreading seed into the treated Phragmites patch here. And the inset photo is just a photo of the actual tag that came on the bag from the nursery. Task 5 was to develop and install an interpretive sign panel. So in order to accomplish this, we gathered input from various stakeholders, but primarily Sliloprison and New York State DC. The input that we gathered during this process was that there's a real desire to focus on species, photographs, and content that are specific to the site, but also very important and a high priority for all the stakeholders. So what you see here is a draft copy of the sign that's to be installed at South Sandy Creek. It's currently being printed by Riot Creative Imaging and is scheduled to be installed in early January of 2022. This is a rough outline of showing how the sign is to be constructed. It's fairly simple. It's made up of plexiglass. It's mounted to treated timbers. It's weatherproof, resistant to graffiti, generally low maintenance. And the inset photo here shows approximately where that sign is going to be positioned at the canoe launch and parking lot at South Sandy Creek. Now, finally, task 6, we had resilient and connected landscapes. The objective here again was to utilize 10% of the project budget for invasive species treatment and or habitat restoration activities in the areas adjacent to those indicated in the RFP. So our initial survey of the invasive species treatment areas in May of 2021 showed us pretty early on that the populations that we were going to be treating extended quite a ways inland and away from what was indicated on the RFP. We knew that the areas to be treated were larger than what was mapped out there as part of the RFP. So knowing that we were going to have a difficult time finding loosestrife beetles and that we already had to put 10% of the budget towards controlling areas outside of the original RFP units, we followed the knotweed inland essentially and the Phragmites to a lesser extent. So the RFP requirement initially required Japanese knotweed treatments totaling 2.03 acres and common reed treatments of 0.3 of an acre for a total treatment area of 2.33 acres. After mapping everything out there, the actual area treated was 2.7 acres of knotweed, 0.34 acres of common reed, so totaling 3.04 acres, or 130% of the planned area was treated. So quite a bit more than what was treated originally, but makes some sense when you consider that the loosestrife beetle release was not possible for this year. So finally, I have some conclusions and next steps, and these are just Sliloprison asked us to come up with a list of thoughts about where the project may go next. And really the next obvious phase is evaluating the 2021 invasive species treatment with vegetation monitoring of some sort. Some of the things you may look at would be the general effectivity of the treatments. What was the overall reduction 1 year following the initial treatment? If there are any knotweed or Phragmites plants growing, probably be interesting to look at, are those seedlings or are those resprouts from rootstock? Oftentimes when you're treating large populations or monocultures of invasives, you get a halo of surviving stems around the perimeter, or that's where it's important to come in and do a follow-up during year 2 to make sure those don't reinvade the areas you just cleared. It'd be interesting to look at the redevelopment of the areas with biomass removal versus those without, if there's much of a difference, if it's worth the extra cost to do that. Look to compare areas with stem injection or wiping versus the areas treated with foliar application. Same chemical, slightly different concentrations, but different application method may result in some different mortality rates there. We thought it would be interesting to do a botanical inventory of the treated areas that were seeded, and then compare those to nearby reference areas that were not treated. So comparing the newly established vegetation with what's present outside the treatment areas, and what's the what the diversity looks like, what the dominant species are, things like that. And then within the areas that were revegetated, look at the seed species that are germinating and growing, what's doing well, what's not doing well, and using that information to potentially tailor future reseeding or revegetation efforts, so you can get your most bang for your buck when it comes to reseeding those areas. We'd also recommend continuing invasive species treatments, particularly upstream of the treatment areas, as Phragmites and knotweed tend to grow not only from seed, but also potentially from plant fragments during flooding events. That a lot of that material is going to come from upstream versus downstream. So we thought that it would be a good idea to look upstream and try to take care of additional sources that don't cause reinfestation. And then finally, just continuation of the invasive species treatment following the knotweed in particular into the upland. We know there is more knotweed, particularly to the south of the project area. I think if I'd have let our crew go, they would have continued to follow it until it was done, but we ran out of time and budget out there. So there is more invasive species to be controlled. So that is the end of my presentation. Appreciate your time for watching. If you have any questions or want to discuss any component of it, my contact information is here. But I appreciate the time. Thanks, Brittany.
Thank you so much for your presentation, Ryan. We appreciate it from Slilo Prism as well. And if anyone watching this is interested in more information about the Aquatic Restoration Initiative from the Slilo Prism, you can contact me, Brittany Rogers, or you can visit our website at sliloinvasives.org. Thank you again, Ryan, and have a great day, all.